Well, hello and welcome back. All right, so what we learned about in 5.5a, or the first part of 5.5, was how to solve exponential equations and logarithmic equations where both sides could be written with the same base, so to speak, right? So what we're going to do in this video is show you what's our goal, what's our strategy when that's not the case. Because just looking down at these two problems, these are exponentials, and we can see right away there's no number I could write 10 and 2001 as the same exponential base raised to some power, right? It's not possible. So here's our goal when we find ourselves in that situation. If we're dealing with exponential equations such as this, what we're going to do is we're going to use either the common log, which is log, or the natural log, right, which is our ln. Doesn't matter which one you use, but we're going to use that log and the rules of logs to simplify by changing forms. Okay, so I'll show you what that looks like here in just a minute. Hopefully we can do some easy ones, and we'll be able to get some practice knowing which one might best suit the problem we're working on, right? If we see a 10 or some factor of 10, not factor, some multiple of 10, we may want to use the log. If we see an e, then we're probably going to want to use ln, right? Okay, so that's for exponentials. And then when we get into logs, what we're going to do for logs, it kind of is the same as what we did when we do have logs on both sides, is we're going to condense it down as far as we can so that we have one log term on one side and then just a number on the other side. And then what we'll be able to do is change forms to solve. Okay, so that's where we're heading. That's the two things we're going to look at to do, and then we're going to do some mixed review. Okay, so let's look at exponentials first. So the first exponential, I clearly can't write this as 10 to some power and this is 10 to some power. So what I want to do is I want to put a log on these terms, because if I can put a log on this term, then I can bring that unknown out of the exponent. So looking at the two bases I have here, and I'm trying to determine if I should use my common log or my natural log, I'm actually going to use my common log for this one because it has an exponential base 10, and a common log is base 10. So that might actually help us a little bit. So I'm just going to use log of 10 to the x minus 1 is equal to log of 2001. Okay, so I'm just evaluating both sides with a log, and that's okay. I'm not changing my equality as long as I do it to both sides. Okay, but the reason that I did that is because now I can use my power rule. Remember, my power rule is if I, in a log, right, I can only do this if there's a log there, is that I can take this exponent and bring it down as a coefficient, right? Now, notice when I brought it down as a coefficient, I am using parentheses because there's more than one term. Okay, if there's more than one term, we have to use parentheses. In this case, my log and my 10 is going to cancel out, but that won't always be the case. So if this doesn't cancel out, we would then have to distribute it into this. Okay, but this is a special case. Log base 10 of 10 cancels out to just 1, right? And 1 times x minus 9 is just x minus 9, right? Or you could have canceled it right here. The reason that I'm showing that you bring this down is because that's the strategy we're going to use on the other problems where it doesn't cancel out, all right? And then on the other side, I just have log of 2001. So this is where you need to bring out your handy-dandy calculator. And I'm actually going to kind of work along with you because I want to show you how to keep all your decimal places if that's something that you tend to miss problems on because you're not keeping all your decimal places. So the first thing I want to do is I want to go ahead and I could move my 9 over, but I'm not gonna, because this 9 is not going to be inside that log. So I'm going to get a decimal for this log first of all. So x minus 9 is equal to, I'm going to do log of 2001, and that gives me 3.301 and some more stuff, right? So now that I have that, now in terms of solving, I need to move my 9 over. So I'm going to add 9 to both sides. So x is equal to, when I add 9, I'm going to do it on my calculator, so I save all my decimal points. I get 12.3012, blah, blah, blah. Okay, so make sure you leave all the decimal points on until you get ready to round. So if I look at my instructions here, it says round your answer to the nearest hundredth. Okay, hundredth is 2 decimal places. So when I look at my answer, 1, 2, my second decimal place is the 0 because there's a 1 behind it that does not round it up. So that means my answer here would be approximately 12.30. Okay. On an exam, I don't care if you put the 0 if the last one is a 0. But in my math lab, if they specifically say to round it to the 100th, make sure you have a 0 in there to represent the 100th place. Okay. All right, let's look at another one. Same idea here. First thing is I want to make sure that my exponential base is isolated. So right now my exponential base is e to the 3x, and it's not isolated because I have this 2 here. So I'm going to go ahead and just divide off that 2. So that's going to give me e to the 3x is equal to 72.5. So now that we have isolated the exponential base, now I need to be able to solve for x. And I can't just get rid of this e and bring this x down to a normal number, right, as it is. I can only do that if I have a log. So the log that I want to choose for this problem, because I could use log or ln, I obviously want to use ln for this one because ln is the inverse of e. So I'm going to do ln of e to the 3x is equal to ln of 72.5. Okay. And then again, you can either cancel your ln e here, or you can use your power rule to bring the 3x down. Okay. I'm going to go ahead and write it as bringing the 3x down, which is 3x ln e. And then I'm going to cancel my ln e. Again, if you want to cancel it right here, that's totally fine. I'm just showing this step because this is what we're going to see later on for ones that don't cancel. Okay. And on the other side, so here we just have 3x is equal to ln of 72.5. And now this is something I should be able to do on my calculator, right? So again, I would do ln of 72.5 first. So ln of 72.5, which gives me 3x is equal to 4.283 and some more stuff, right? And then I want to go ahead and divide off that 3. So I'm going to divide by 3, which gives me 1.4278 and some more stuff, right? And then again, my instructions said to round to the nearest hundredth. So that's 2 decimal places. So my second decimal place is this 2. Because it has a 7 behind it, that's going to bump it up. So we're going to say this is approximately 1.43. Okay? All right. Let's look at some more. Maybe we're not highly offended. All right. Okay. When we look at this first one, e to the negative c and 8 to the 2c. The first thing that I notice is it's not a log. I don't need stars. Yay, no checking answers. But I also notice that e and 8 cannot be written with the same exponential base, right? So if they cannot be written with the same exponential base, I have to use a strategy to get those unknowns out of the exponent. And my strategy is to just put a log on both sides. Now the log that I want to use, if I can choose between log or ln, is I'm going to choose ln because I see an e, right? So I'm going to do ln of e to the negative c is equal to ln of 8 to the 2c. Okay. So again, now that I have my ln's, I can bring those powers down. So I can bring the negative c down, and I can bring down the 2c. So I have negative c times ln e is equal to 2c ln 8. Okay. Now, just like before, ln and e is going to cancel out. Those are inverse functions. So really what I'm left with is negative c is equal to 2c ln 8. 2c ln 8 is all one term. Okay. It is a term that contains c, which is what I'm solving for, right? So I have this term that contains c, and I have this term that contains c. So I need all my terms on the same side. So I'm going to go ahead and add my c to this side. So that gives me 0 is equal to. Now, I can't add these technically because this one has all this other junk attached to it. So they're not like terms. So I'm just going to write it as c plus 2c ln 8, right? Sorry, I'll make my L bigger. ln 8. And I suggest using a cursive ln or a capital ln so that your L's don't start looking like ones and you get yourself confused. Okay. Now remember, we're solving for c, and c right now is in this term and it's in this term. So the way that we can solve for c, get it by itself, is to factor it out. So if I take a c out of each term, this term is going to be left with a 1. This term is going to be left with 2 ln 8, right? And 2 ln 8, this is just some number, right? If I punch this into my calculator, it's going to give me some decimal number. So the last thing I want to do to get c by itself is just divide off this number that's being multiplied by it. So I'm just going to divide off 1 plus 2 ln 8, divide off 1 plus 2 ln 8. So that way it cancels. On this side, 0 divided by a number is still just 0. So we end up with c equals 0. Not too bad, right? Take the ln of both sides so we can bring those exponents down in front and then solve for our unknown. Okay, let's look at another one. This one, our exponential bases are 2 and 5. So 2 and 5 don't have a common base that I can write this, both sides as the same. And here it really doesn't matter because I don't have a 10 and I don't have an e. So it really doesn't matter which log I choose to use because it's not going to cancel one of these numbers out, right? So I'm going to choose to use ln, mainly because I only have to write 2 letters instead of 3. But I'm going to go ahead and take the ln of both sides. So I have the ln of 2 to the 5th power is equal to ln of 5 to the 4 over x power. Okay. And the reason I'm inputting that log there on both sides is so I can then use the power rule of logs to bring down those exponents, right? So now I'm going to have 5 ln 2 is equal to 4 over x times ln 5. Okay. And then from here, this is something I should be able to solve for. Okay. Remember, I'm solving for x. Everything else is just normal numbers. Okay. So right now, x is stuck in the denominator. So if I want to get x out of the denominator, I have to multiply both sides by x. So I'm going to multiply this side by x, and I'm going to multiply this side by x. And in doing so, this side, my x's will cancel. So now I have x times 5 ln 2 is equal to 4 ln 5. Okay. And then you could see, now normally when we multiply by x, I would probably write this as 5x ln 2. We just write the x in the front with the number. But I specifically left it kind of out to the side because I'm solving for x. So this makes it easy for me to see that this is what I need to get rid of in order to get x by itself. So I'm just going to go ahead and divide this side by 5 ln 2, divide this side by 5 ln 2. So x is equal to 4 ln 5 over 5 ln 2. Okay. Now, these are the kind of steps I want to see when I'm grading your exams. Okay. So if you go straight from this to like magically having an answer, I know that you're using a math app, or I know that you're just cheating, basically, right? So justify your answer to me through your work, through showing your work. So if you have a more basic calculator, you're probably going to have to get an approximation for this number and an approximation for this number, and then divide those two approximations. I like to just do the top and then divide it by the bottom. So when I do the top, I get 4 ln 5, right? That's the top of my fraction. Enter, right? So if you're somebody who's writing out approximation, you can put that here. And then we're going to divide it by this bottom. So divided by the bottom piece, which is 5 ln 2. Enter. And so what we end up with is 0.89246 and a whole bunch of other stuff, right? We're going to go with the same rounding rules that we had on the last page, which is to round to the nearest hundredth. So 2 decimal places would be the 9. And because there's a 2 behind it, it's not going to round up. So we're going to say this is approximately 0.89. Okay? Something new and exciting, maybe. All right. Let me show you 2 more that look a little bit more intense, but it's really just more of the same, just seeing that same thing in different examples. Okay, so I'm going to do these 2 examples, and then I'll have y'all practice some. All right. Okay, so let's look at our first one. I see that the 4 and the 7 are not common bases. Right? They do not have a common base. They can be written as the same on both sides. So I'm going to use either a log or an ln to get those unknowns out of the exponent. And it doesn't matter which one I use here because I don't have a 10 and I don't have an e, so nothing's going to cancel out. I'm going to use an ln just because less letters to write. So I'm going to do ln of 4 to the 7x minus 2 is equal to ln of 7x. Okay, and the reason I'm doing that is so I can get those x's out of the exponent. I can bring those down using the power rule of logs. So that's going to give me 7x minus 2 times my ln 4 term, and that's going to give me on the other side an x in front of my ln 7 term. Okay, so now that I have those powers brought down, now this is just a solving game, okay? A solving game where I'm trying to get x by itself. So right now, I see that there's an x in this term, and I also see that there's an x stuck in this quantity. So I need to get this x out of this quantity first. And the way that I get it out of a quantity is that I go ahead and just multiply whatever multiplication is happening to that quantity. So I'm going to distribute this ln 4 to both terms. Okay, so when I distribute it to 7x, I'll get 7x ln 4. And when I distribute it to negative 2, I get negative 2 ln 4. And that's going to be equal to x ln 7. So just to keep perspective, we're solving for x. So this term has an x, and this term has an x. So any terms that have x's, I need to get all those terms on the same side of the equation. So I'm going to go ahead and move this 7x ln 4 to the other side. So I'm going to subtract 7x ln 4 minus 7x ln 4. So that leaves me with 2 ln 4 is equal to. Now, as badly as I would like to just subtract straight down because it looks like I can't. These are not like terms. They don't have the same ln values, so I'm just going to write them out side by side. So this gives me x ln 7 minus 7x ln 4. Okay. Again, solving for x. I have an x in this term, and I have an x in this term. So if we have our unknowns trapped in 2 separate terms, the way that we can get that x by itself is by factoring it out. So if I factor out that x, this first term, when I take its x away, is going to be left with just ln 7. And the second term, when I take its x away, I'm going to be left with negative 7 ln 4. Okay. I know it seems nasty, right? Because there's a lot of letters, but we're just solving by getting x by itself. So now what we have is x times some number. So we want x by itself. So it's being multiplied by some number. The way that we get it by itself is we divide off that number. Okay, so we divide off this number, minus 7 ln 4. Okay, so what this is saying, I'm just going to rewrite it down here below, is that x is equal to negative 2 ln 4 divided by ln of 7 minus 7 ln of 4. Okay, and so this is what we need to calculate on our calculator and get a decimal approximation, right? So the way I like to do it, you can approximate the top and approximate the bottom and then divide those approximations, or you should be able to do it all in one step. Let's see. Negative 2 ln 4 on top, and I'm just going to go ahead and get an answer for that, okay? And then I'm going to divide. Now I have to divide this whole mess. So I need to put parentheses around this when I put it in my calculator to show this whole thing is getting divided off. So I'm going to put parentheses, ln 7, and I'm going to close the parentheses to show that that's all that's inside that ln. And then I'm going to do my minus 7 times ln 4. And then I need to close those parentheses to show that's all that's in that ln. And then I'm going to close the parentheses that say, okay, that's the end of everything that's in the denominator. And that leaves me with x is equal to 0.3573 and a whole bunch of other stuff. Okay. And then I just need to round it to the second decimal place, or to the nearest hundredth, which is the 5 place here. Since there's a 7 behind it, that's going to round up. So we're going to say this is approximately 0.36. And again, I'm not checking any of these answers because we're still dealing in exponential problems. Okay? All right, let's look at this last one, and then I'll have y'all try some. So on this one, remember the way that we start every exponential is to make sure the exponential thing, right, is isolated. So right now it's not isolated. This is the big mess that has an exponent. So I want this big mess to be isolated. So the first thing I'm going to do is divide off the 3,500. Okay, I'm going to divide 3,500 on both sides. Now 7,000 divided by 3,500 leaves me with just 2 is equal to my big mess, 365 raised to the 365t. Okay, now I want to go ahead and do, we are eventually just going to get a decimal for this, but it's not a pretty decimal. So I'm going to wait until I'm ready to punch it into my calculator before I calculate what that is. Okay, what I'm focused on most is getting this t out of the exponent so that I can solve for t. And the only way to be able to bring this down is if I have a log there. So I'm going to go ahead and take the log of both sides, or the ln. Okay, doesn't matter which one. I'm going to use the ln. So I have the ln of 2 is equal to the ln of 1 plus 0.027 over 365 raised to the 365t. And the reason that I took that ln is so that I can now use the power rule to bring this exponent down in front of my log. So now it looks like ln 2 is equal to 365t times the ln of 1 plus 0.027 over 365. Okay. And now I just got to figure out how to solve this. All right, so when I look at it, and I'm sorry, my work kind of ran together here. All right, so when I look at this one, I'm solving for t. That's the thing I want to get by itself, right? So what I need to get rid of, basically, is I need to get rid of this 365 and I need to get rid of this ln of big, fat, ugly mess, right? So what I'm going to do is I'm going to go ahead and figure out what this equals as a decimal, and then I can get rid of that number and this number by just dividing it off, right? Because really I could rewrite this to look like this. I could say, okay, well, here's my, and I'll leave it orange just so that we can see it. Here's my t times 365 times whatever this equals. So I'm going to go ahead and see what this equals. So to punch that into my calculator, order of operation says I need to do this division first. So 0.027 divided by 365. And then I need to add the 1, so plus 1. Okay, so that's what this inside piece equals. Now I need to take the ln of it. So I'm going to do ln of my last answer. And that's what I get. So this is basically how many zeros is that? 4? 1, 2, 3, 4, 7, 3, 9, 7. Okay. So what I want to do to solve for t is I want to divide these two numbers off to get t by itself. So I'm going to go ahead and multiply them together just so I have one number to divide off instead of two numbers to divide off. So I'm going to take this number and multiply it by 365. So what that gives me, I have ln of 2 is equal to t times this number that I got when I multiplied these two together, which, if you can see my calculator screen, is 0.02699 blah 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 and some more stuff, right? So now to get t by itself, all I have to do is divide off that 0.02699 number on both sides. Now we want to make sure that we're keeping all of our decimal places, okay? So I'm going to leave all these decimal places on my calculator, and what I need to do is I need to do the ln of 2 divided by that number. So I'm going to do ln of 2 divided by, and if I use a second function, I can put in my last answer. Okay? And that gives me 25.67306 blah blah blah, more stuff, right? So again, I'm going to go ahead and round to the hundredths place, which is 2 decimal places. So that's my 7. Because there's a 3 behind the 7, that is not going to round up. So this becomes t is approximately 25.67 when we solve this second piece. Okay. All right. So on the next page, I think it's just one page. Yes. On the next page, there's 2 for y'all to try. Go ahead and jump into it. See how you do. If you get stuck or if you get finished and you just need to check yourself, go ahead and unpause the video to see me talk through it. Okay. But for now, go ahead and pause it and give those a whirl. All right. Let's go ahead and see how you did. On number 1, again, we want to get our exponential base isolated. So we divide off the 35, which leaves us with 2 is equal to e to the 10r. Then the best case scenario here is to choose ln, because ln will cancel out the e, right? Now, if you canceled it here, or if you brought the 10r down first and then canceled it, either way is fine with me. Okay, so you should be left with ln of 2 is equal to 10r. And then to get r by itself, we just divide off the 10. Okay, so this is what we can do in our calculator. ln of 2 divided by 10. If you have a more basic calculator, you probably have to do it in steps like I showed here. But regardless, we should end up with 0.0693. And then when we round our answer, we should end up with 0.07. Okay, all right. Now I want to show you number 2. Number 2 is a little bit different because we didn't have an e, right? So nothing's going to cancel out here, but we still go ahead and use ln so that we can bring those exponents down. So that's going to leave me with x ln 7 is equal to, now notice because I had 2 terms that I'm bringing down out of that exponent, I put parentheses around it. Okay, so this is going to turn into 2 terms once I go ahead and multiply in this ln 3. So ln 3 times 2x is 2x ln 3. and ln 3 times negative 1 is negative ln 3. So you can see I have an x in this term and I have an x in this term. So these two terms need to end up on the same side of the street, right? So I'm going to move this one to the other side by subtracting. So that gives me x ln 7 minus this 2x ln 3 that I brought from the other side is equal to negative ln 3. And now to get the x out of these terms, right, I just factored it out like a greatest common factor, which leaves me with ln 7 minus 2 ln 3. So basically this is saying I have x times some number. So if I want to get x by itself, I have to divide off this number. And I didn't actually write it in, I just showed with parentheses. I'm dividing off that quantity, I'm dividing off that quantity because I didn't have much room over here. So I have my negative ln 3 on top, and I have this quantity that I divided off of ln 7 minus 2 ln 3. Now, if your calculator's smart enough to do this all in one step, you can go straight to here. If you have a more basic calculator, you probably have to calculate the top and calculate the bottom and then divide the two, okay? All right, so that was all about exponential equations that we can't write both sides with the same exponential base. Okay, so now what I want to look at is log equations where we can't write both sides with the same log. Because remember, our method before was get one log term and then drop the logs, right? But if we have problems like this, right, I have one log term on this side, but this side I don't have a log at all. So we have a different strategy. So our strategy is that we want to condense so that we have one log term isolated. One log term isolated on one side all by itself. And then we're going to change forms to solve. Okay, so isolate the log and then change forms. So let's look at some. It does say here that when needed, we're going to round to the nearest hundredth. Okay, doesn't necessarily mean they're all going to come out ugly, but it means there's a potential that they're going to come out ugly. And if they do, we can have a rounded decimal answer. Okay. All right. So first thing I'm going to do is I see I'm solving a log equation. So I'm going to put my stars to tell me, I have to check my answer on logs. I have to check my answer on logs. Okay. Then I want to isolate one log term. Okay. I want only one log term on one side of the equation. So right now I do have only one log term, but it's not completely isolated because I have a coefficient on it. So there's two ways I could get rid of this coefficient. I could either move it up into the exponent, which would give me a cubed quantity, or I could divide it off. And here, dividing it off doesn't pose any threat because I don't have a log over here that it's going to mess up, right? So I'm going to start by just dividing both sides by 3. So that's going to give me log base 2 of x minus 1 is equal to 2, right? So now I have my one log term and it's isolated and it's equal to a regular number, okay? So now what we want to do is we want to change forms. And what I mean by change forms is I want to change this from a log problem to an exponential problem. So remember way back when we first kind of introduced logs, the way that we can get rid of a log is by using the exponential base. So I just look, what log base does this have? What has log base 2? So I'm going to use exponential base 2 and move this up into the exponent of my 2. So that gives me 2 raised to the log base 2 of x minus 2. And that's going to be equal to 2 raised to the 2. So notice, I'm not changing the equation at all. The only thing I'm doing is I'm putting in this big exponential base 2 on both sides, right? The original equation is still there. And the reason I can do this, by the way, is because remember we had that thing that said if a to the x equals a to the y, then that means x equals y, right? Or in other words, if I have the same exponential base, I can just drop them, right? So same exponential base, I can just drop it and I'm left with the exponents. It works in this direction too. If I have an equation, I can actually just move that equation up into the exponent and stick in whatever exponential bases I want. So that's what I'm doing here. I'm sticking in the exponential base that will specifically cancel out my log. So these will cancel, and that leaves me with x minus 1 is equal to 4. And now that's something really easy to solve. So I just add my 1, which gives me x equals 5. I'm not going to circle it because this is a log problem, right? So we do have to check our answer. So I look for the inside value of my logs, which the only inside value I have here is this quantity x minus 1. And if I check x equals 5, if I plug 5 in here, 5 minus 1 is 4, not 0, not negative, so that works. So this is my answer. Okay, let's look at another one. This one, first thing I see, log equation. So I'm going to put stars so I remember to check my answer. Okay, then I want to make sure I have one log isolated and just a number on the other side. So if I look at this one, I do. I have one log term isolated and just a number on the other side. So now I can go ahead and go straight into changing forms. Okay, so to get rid of a log base 7, I need to put in an exponential base 7. So I'm going to use a different color to do that. I want to put a big exponential base 7 on both sides. Okay, so that means on this side I have 7 raised to the log base 7 of negative x. And that's going to equal 7 squared. So all I did was move my equation up into the exponent of these exponential base 7s. And the reason I chose 7 is so that my log and my exponential base 7 would cancel. So that leaves me with negative x is equal to 49 when I square the 7. And then to solve for x, I just divide or multiply off that negative, which means x equals negative 49. Because this came from a log, I do have to check the answer. So the only quantity that I had inside the log was a negative x. And I'm checking negative 49. So if I plug a negative x in, or sorry, a negative 49 into negative x, that's going to give me double negatives, which makes it a positive 49. So it does not give me any issues. So x equals negative 49 is my solution. Okay? Maybe not too bad. Let me look at a few more, and then I'll have y'all try some. All right. So first thing I noticed right away is all of these are log problems. So we should be putting our stars so we don't forget to change, to check our answer, right? So I look. Is this log term completely isolated? It is. It's on one side all by itself. It's the only log term and there's no coefficient. So I can go ahead and use my exponential base. So I'm going to put in whatever exponential base will cancel out this log. This is log base 16. So I'm going to use exponential base 16 and move my equation up into the exponent. Okay? But if I do it on one side, I got to do it on the other side. Okay, so that gives me 16 raised to the log base 16 of x. So those are going to cancel. And I have x is equal to 16 to the negative 3/4. Now, there's a couple of issues here. I have a fraction exponent, which I need to simplify. But I also have a negative exponent. And we can't calculate things when we have a negative exponent. So the first thing I want to do is get rid of this negative. And the way that I change the sign of the exponent is by moving the entire base across the fraction line, right? So I'm going to go ahead and move this whole thing down to the denominator. So I have 1 over 16 to the 3/4 power. Okay. And then remember, a fraction exponent represents power over root, right? We went over this when we were talking about expanding and condensing. So I should be able to write this in a radical form. So power over root. So the root here is 4. So I'm taking the 4th root of 16 and then I'm raising it to this power, which is the 3rd power. Okay, So I just need to simplify this. If you don't know what the fourth root of 16 is off the top of your head, you're looking for 4 copies of a number, right? So you can always prime factor this. 16 is 4 times 4, right? And then each of these 4s is 2 times 2. So you can see here I have 4 copies of 2, which means that the fourth root of 16 is 2. So that gives me 1 over 2. But then remember, it was raised to the third power. So now I have to raise that to the third power. So I get 1/8. Okay. So this was an example of super easy to convert to exponential form, but then maybe a little bit of extra work to finagle it to get our actual answer once it's in exponential form. Okay. All right, let me look at 2 more. This one on the top right-hand side of the page, I see it's a log equation. So I'm going to go ahead and put my stars. And now I need to change forms because the log is already isolated. It's equal to a number. Now, what is my base here if it's an ln? Right? There's not a little number written there. So ln, remember, is log base e. So to get rid of an ln, I'm going to put in an exponential base e. So e raised to the ln of x plus 1 is equal to e raised to the third power. So I'm putting in that exponential base so that I can cancel my e and my ln. So that leaves me with x plus 1 is equal to e cubed. Now remember, e is just a button on our calculator, right? We should all have an e button on our calculator. Some of your buttons may look like e to the x. Okay, so mine is, mine's a second function here on the ln. So I'm going to use that second function. So you can see it says e to what power do I want? And I'm just going to type in 3. So I can do e to the third power. So this gives me x plus 1 is equal to 20.085 and a bunch of other stuff. Okay, and then to solve for x, I subtract 1. So I have x is equal to 19.085 and a bunch of other stuff. And remember, on all these problems, we're rounding to the nearest hundredth when needed. So that's 2 decimal places. So if I go to my second decimal place, which is an 8, I have a 5 behind it, so that's going to bump it up. So we're going to say this is approximately 19.09. And before I circle my answer and get all excited, I'm going to remember that this was a log problem, so I have to check my answer. So I'm going to come down here and say we're going to check to make sure that inside log value, which here was x plus 1, is not made 0 or negative by my solution. So my solution was 19.09, and if I plug that in here and add 1 to it, that's going to work just fine. So I can go ahead and circle my answer. Okay. All right, let me show you one more, and then I'll let you do something, okay? All right, so this one at the bottom left-hand side of the page looks a little bit different. It's a little bit different for a couple of reasons. If you notice, looking at it compared to the other two, the x is actually not inside the log as an unknown, right? It's actually up in the exponent, right? So I don't have to check my answer on this one. Even though it has a log, the log itself is in the exponent position. And x is in the exponent can be anything. We have no restrictions, okay? So I'm not going to put my stars on this one because the x is in the exponent. So now I want to see, okay, well, how can I solve this? I could use a big exponential base 3, but I actually see an easier way to solve this because I see that this is log base 3, and inside it I see a 9. And 9 can be written as a power of 3, right? I can rewrite this as 3 squared, right? So I need to put back on the exponent that it already had, which was 2x. And I'm going to go ahead and write in the log base 3. And now log base 3 and 3 should cancel, right? But I can't cancel it until I've simplified my exponent. So this gives me log base 3 of 3 to the 4x is equal to -2. And now I can go ahead and cancel log base 3 and 3, which means that 4x equals -2. And then to get my x all by itself, all I have to do is divide off that 4. So x equals -1/2. And again, I don't have to check it. I'm going to say no check required. Yay. And that's because the variable is in the exponent. Okay, if the variable was inside the log, like where the 9 or the 3 is located, then we would have to check it. But because that x is up in the exponent, we're not required to check this one. Okay. Okay, so on the next page, there are four for you to try. Okay, so go ahead and pause the video and give those 4 a shot. If you get stuck on one, that's okay. Just skip it, try the other ones. And then whenever you're ready, unpause the video and we'll go over them, okay? All right, so let's see how you did. On the first one, I see that it is a log equation, so I know I am going to have to check my answer. And I see that it's already one log term isolated equal to a number. So I'm going to insert the exponential base that will cancel out log base 9, which would be exponential base 9. So I put in the exponential base 9 on both sides. That way it cancels on the left, leaves me with 2x minus 1 equals 9 squared, which I simplified to 81. And when you finish solving this out, you should get 41. Don't forget to check it because it is a log, okay? Let's look at the second one. Second one was a little bit tricky, right? There's a whole lot going on there, but it's still just one log, which is equal to one number. So we can get rid of the log by using the exponential base that will cancel out a common log. Common log, remember, is log base 10. So I'm going to use an exponential base 10 on both sides, which will cancel it out on the left. And this says that x to the 10th equals 10 to the 10th. Well, the only way that this could be true, if this number raised to the 10th equals 10 to the 10th, well, that means that that number has to be 10, right? So kind of just a thoughtful way of solving that one. And once I have my answer of 10, because it did come from the inside of a log, I do have to check. And obviously, if I raise 10 to the 10th power, it's not going to be 0. It's not going to be negative. So that is our answer. Okay. All right. Let's look at number 3. I don't know where to put it where there's not a glare. Okay, there we go. All right. So on this one, same idea. I have to get the log completely isolated first. So don't start doing your big exponential base 4 until you get rid of that 5. Okay, and it's a lot easier for us just to divide the 5 off than to deal with a quantity that's to the 5th power, right? So we divide the 5 off, that isolates our log, and now we can go ahead and get rid of that log by using its exponential base. Be sure you're doing the exponential base on both sides, okay? That way it cancels on the left, and on the right-hand side, 4 squared gives us 16. So the answer I should get once you work it out is 10. And then again, we have to check to make sure that the answer we got doesn't cause the inside of that log to be 0 or negative. Okay. And then the last one that we have here is an E1. An E1, right? We have a natural log. It's already isolated and equal to -1. So the base here is E. So to get rid of a natural log or an ln, we're going to use exponential base E. Be sure you do it on both sides. E and ln are going to cancel, which leaves me with just a 2x on the left-hand side. And then the right-hand side, I can calculate using my calculator. E to the -1, whatever that equals, then we're going to divide it by 2. Okay, which should give us 0.1839, and we're rounding to the nearest hundredth. Okay, so we get our answer, we check it to make sure it works, and then we're done. Okay, all right, so now we've been through all of the different types of solving strategies. If the bases are the same, if the bases aren't the same, if we have an exponential, if we have a log. So now I just want to go over kind of some mixed review of all the different things we've learned and see if we can think through how to do it. Okay, so the first thing I see on this one is that it is a log problem. Log problem means that I need to check my answer, so I'm going to put my stars there. The next thing I see is that this log equation does not have logs on every term, right? I have a regular number term. So if I have a term that does not have a log, that tells me I'm not going to be able to just drop them, okay? But I still want to get one log term is equal to my regular number. So I'm going to go ahead and condense this side, okay? It's an addition, and we know that addition condenses to multiplication, right? So I can write this as log of x minus 2 times x plus 2 is equal to 2, right? So I'm just condensing it down into one log, and now this looks just like the ones we got done doing, right? In order to get rid of this log, because I can't drop it, right? Because that side doesn't have one. If it had one, I could drop it and that would be really easy. But I don't have one over here, so I have to change forms, okay? Change forms. So this is a common log. Common log, remember, is base 10. So I'm going to put in an exponential base 10 on both sides. So exponential base 10 raised to the log base 10 of x minus 2 times x plus 2 is equal to exponential base 10 raised to the second power. Make sure you're putting that 10 in on both sides, okay? That way it cancels on the left. So we have x minus 2 times x plus 2 is equal to 100, right? Or 10 squared, which is 100. And now we just need to go ahead and work this out. So I'm going to go ahead and FOIL this out. X times x is x squared. X times 2 is 2x. Negative 2 times x is negative 2x. And negative 2 times positive 2 is negative 4. Okay. So notice here my x terms are opposites, so those combine to 0. So I have x squared minus 4 equals 100. And because I don't have an x term anymore, I'm going to use the square root method to solve this one. So I'm going to move my 4 to the other side. So I have x squared is equal to 104. And remember, if you use the square root to solve, you have to remember your plus or minus. Okay? So I get x is equal to plus or minus the square root of 104, which gives me x is equal to plus or minus 10.1980, blah, 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 right? We're going to round to 2 decimal places, which would be this number right here, this 9. And since there's an 8 behind it, that's going to bump this 9 up, right? So instead of having 0.19, we're going to have 0.20. So I have x is equal to 10.20 and x is equal to negative 10.20, right? And because it came from a log problem, we have to check our answers. And the 2 inside values that we had inside our logs was x minus 2 and x plus 2, right? So notice if I have 10.2 and I subtract 2 from it, that's still okay. That's still a positive number, right? If I do 10.2 and I add 2 to it, that's also okay. So I know this one is a solution. When I check negative 10.2, negative 10.2 subtracted 2 gives me negative 12 point something, right? So that is a no. So we know that one is not a solution, okay? So this one was just like the ones we just did. The only difference was we had to condense first. Okay, so notice whether we have logs on everything or we don't have logs on everything, we always condense. And then once we condense, if we have 1 log is equal to 1 log, we drop logs. If we have 1 log is equal to a number, then we change forms. Okay, all right. Here's the page I need. All right, so same idea on this one. Notice there's 2 ways I could solve this. 2, count them 2, 2, 2. I could condense these ln's so that I have 1 ln term equals 0. Or, since this is a 0 over here, there's not like a regular number. I mean, I know 0 is a regular number, but like it changed, 0 doesn't matter if I put something else on this side. I'm actually going to go ahead and move my ln x to the other side. That way I have ln 4 is equal to ln x. Oops, and this is one that I'm going to have to check, right? But the reason that I did it this way is because this is a lot easier to solve, right? I have 1 ln is equal to 1 ln, so I can drop the ln's. So this means that x is equal to 4. And then I just have to check my answer. So my inside values are a 4 and an x. And if I'm checking x equals 4, well, that doesn't change the value. And if I plug a 4 in here, it's positive. So I have no issues. Not too bad, right? All right, let's look at our next one. Next one, okay, we can't do that fun little trick on this one, right? Because one, I noticed right away I don't have logs on every single one. This is my regular number, right? If I have a regular number, that tells me I'm going to have to change forms. All right, so the first thing I need to do is condense this side so that I have 1 log is equal to a number, right? So I'm going to condense this side. We know that addition condenses into multiplication. So I can write this as 1 log base 4, and on the inside multiply x minus 3 and 2, right? This is all inside the log. And then I can get rid of the log base, right? So when I look at getting rid of this log, it's log base 4. So I'm going to put in an exponential base 4 to get rid of it. Make sure you put it in on both sides. So this gives me 4 raised to the log base 4 of, and I'm going to go ahead and just multiply this out. 2x minus 6 is equal to 4 raised to the 3rd power. So putting in that exponential base 4 on both sides, that way it will cancel on the left, and I'm left with 2x minus 6 is equal to 4 cubed, which is 64. And then I can just solve for x. So I'm going to add 6 to both sides, which gives me 2x is equal to 70, and then I divide off that 2. So x is equal to 35. Okay, because it came from a log equation, I'm slacking on my stars. I do need to check my answer. Okay, I have 2 inside values. I have x minus 3 and I have 2, which 2 doesn't really matter. It's not going to be changing, but I do need to make sure that 35 does not make either of those become a 0 or a negative. So if I do 35 minus 3, that's not going to give me a 0 or a negative. And then 2 is not going to change from 2. So my answer is 35. Okay? All right. So there are, I believe, 3 for y'all to try. So go ahead and pause it, give those a spin, and then unpause it when you're ready, and we'll go over them. Okay, so let's look at the first one. First one, we have to condense, right? So it condenses into a multiplication, which I went ahead and multiplied out. If you did that on another step, that's fine. When you multiply these out, you should get x squared minus 9. So we condense that into a multiplication. And then to get rid of our log, we should use exponential base 10. So that way our log and our 10 cancel out. And on this side, 10 to the 4th power is 10,000, right? Since I no longer have an x term, I can solve this one by using the square root method. So I'm just going to move my 9 over and then take the square root. Don't forget your plus or minus. I know in this case the negative didn't work, but that's not always the case. Sometimes the negative and the positive answers both work, okay? So make sure you're not forgetting that plus or minus, okay? So our answer should be 100.04 because that's the only one that checked out when we checked it with the inside values of our logs. Okay. Number 2, same idea. We have to condense first. So we condense from addition to multiplication. When we do that multiplication, we get x squared minus 7x, but it's stuck inside this log base 2, right? And notice I can't just drop it because there's no log base 2 on this side. So the way I get rid of a log base 2 when there's not one on the other side is I use the exponential base. So I put in an exponential base on both sides. it cancels on the left, and 2 cubed gives me an 8 on this side. And now this is something I can move everything to, I can move everything to one side and factor it using sum product, okay? When I factor it using sum product and then solve, I get 8 and -1 as my solutions. 8 works, -1 does not, okay? Again, if you need a little extra time on these, feel free to pause the video and go back. But I'm going to go ahead and move on so I can show you number 3. All right, the last one, this is a little bit tricky. I don't even know if I have one like this on the homework anymore, but it's always fun to challenge ourselves, right? So there's a lot of ways to work this problem. Some people started by dividing off the 10, which I hope is everybody's first step, okay? So that way we have a log that's completely isolated, okay? The next thing is, at this point, because this is a common log, you could put an exponential base 10 on both sides. Some of you did that. That's totally fine. What I did is I took this multiplication because I only care about the I. That's what we're solving for. So I could just get rid of this piece, right? So I took this multiplication and extended it or expanded it into 2 addition terms. Because we know just like addition condenses into multiplication, multiplication expands into addition. And the reason I did that is because I saw that I had a common log and I had a base 10. So I know this side is going to cancel out and leave me with just that 12. Okay. So I have 3 equals log I plus 12. I can move that 12 to the other side, which gives me a -9. And then this is the step where I couldn't go any further without changing forms. So this is the step at which I went ahead and put in my exponential base 10s, right? Which made it cancel on one side. So I get I by itself. And on this side, I end up with 10 to the -9. And usually if you get something with this big of a exponent, they won't usually make you multiply it out in MyMathLab, or this would be the type of problem that would have a multiple choice answer bank for you to choose from. Okay. All right. So that is the end of 5.5b. So you should now be able to complete both homework assignments if you haven't yet started on A. And you should be well equipped to solve any exponential or logarithmic equation that I could throw your way. So go ahead and get started on that. If you have any questions, please feel free to ask me.